Hello everyone, and welcome to section 2.4 in Algebra 2 Honors, Modeling with Quadratic Functions. So this chapter you've learned that there are three ways to write a quadratic equation. All three are equally acceptable. It is always going to be up to you to evaluate the given information and determine which one is the easiest to apply, but I will accept any of the three answers. So in the first example, it says, write an equation of the parabola using the given information. It passes through the point -1, 2, and it has a vertex of 4, -9. It doesn't tell me A, B, or C. It doesn't tell me the intercepts, but it does tell me the vertex. So I'm going to go with that form. Y is equal to a times x minus 4 squared. For some reason, people really forget the square a lot. Be careful there. Minus 9. Now, it doesn't tell me a, but I do know that it passes through this point. So you can plug this point in to find a. You're going to work backwards a little bit. You don't need this there permanently, just for a minute. -1 minus 4 squared minus 9. Okay, second place you need to watch out is right here. You might want to, if you were in class, I would say try this on your own and see if you make the common mistake. So you might want to pause the video, try this on your own, and see if you make the common mistake. The A should come out to be 11/25. If it doesn't come out to 11/25, then you're one of the people that make that mistake. All right, here's the mistake. When people go like this, -5 squared, some people do -5 squared and then they subtract 9. But that -5 squared, which is 25, is only attached to the A. It is not attached to the 9. So now this is 11 is equal to 25A. And then, like I said, A is 11/25. How does that help us get the final answer? Well, that was the only part of it that was missing. So it's going to be 11/25, x minus 4 squared minus 9. Oops. Missed there. On the next one, it gives me a point again, but this time it gives me intercepts. So I'm going to use the intercept form. Y is equal to, again, they don't tell me A, but I can find that. The intercepts are -2 and 4, so x plus 2 times x minus 4. I can plug the point 2, 5 in. 5 is equal to A times 2 plus 2 times 2 minus 4. Now these are all three multiplied together. So 4 times -2 is -8A. Do you see the difference? On this one, just this piece was part of the A and then minus 9. That is the biggest mistake. Divide by -8. Now I know what A is. Now I can rewrite this with the A in it. This is an acceptable format for the answer. There is no need to multiply it out. Just stop there. If you multiply it out, and you make a mistake when you're multiplying, I will have to take off, even if this step was correct. So if you choose to continue, you do so at your own risk. You might want to try these next two on your own. So I'm just going to write down the answers. Of course, when I check your notes, I'm going to look for all the work. But this way you have the two answers if you would like to try them on your own. Okay, for those of you that aren't confident yet, allow me to do them. Passes through this point and has this vertex. Again, vertex form is the best choice. y is equal to a times x. It becomes a plus 5. With the x, it's always opposite. Don't forget your square. Plus 9. And then I plug in the negative 15, negative 7. Easy to plug them in backwards because you see the negative 7 first, but the negative 15 has to go in that y spot. I'm going to go ahead and subtract 9 from both sides now, so I don't accidentally add it to that. Negative 7 plus 2 is plus 5 is negative 2, squared is 4. Divide by 4, divide by 4, and I get a is equal to negative 6, which leads me to my answer. I put the negative 6 in. I've already know the vertex, but now I just go back to regular x and y. I just used that point temporarily in order to get the a. And the last one of this type. Again, they gave me x-intercepts, so I'm going to go with intercept form. X minus 9 times x minus 1. Notice that for none of these four did we use standard form. You're not going to use standard form. So now I use 0, 18, negative 18 temporarily. I need it just to find my a. So 0 minus 9 times 0 minus 1. All three are being multiplied together, but people tend to write the number in front. It's a little more user-friendly that way. Divide by 9, divide by 9. A is negative 2. I put that right there where there's supposed to be an a, and I leave it in intercept form. Okay, for the student who does want to multiply these out, maybe because you want to check your answer in the back, I just want to point out that I personally think it's easier to do the FOIL first and then the negative 2. Some people put the negative 2 in one of them. It just makes the FOIL so much harder. But the first, the outers and the inners make negative 10x plus 9. And now distributing the 2 is easy. So if for some reason you feel compelled to multiply it out, do the 2 x's first and then do the number. Given the graph, write the equation for each parabola. This is literally the same problem presented in a different way. Notice in the first one, they gave you the vertex and a point. Notice in the second one, they gave you the 2 x-intercepts and a point. So there's nothing different about these. Don't worry, I'm still going to do them, but I will write the answers in case you would like to try it on your own, which you know is always my preference, that you try these on your own. 1/4 x minus 4 squared minus 1. But when I check your notes, I am going to be checking for the actual work. Okay, so here's the work. I'm going to use vertex form for this one. Y is equal to a times x minus 4 squared minus 1. I'm going to plug this point in. 3 is equal to a times 8 minus 4 squared minus 1. I'm going to add the 1 in the same step that I'm going to simplify this. That way I don't accidentally put those two together. 8 minus 4 is 4 squared is 16a. And I reverse them. No one says a16. I divide by 16, and I get a is equal to 1/4. I put that right there, and I can leave the rest of it the same. It already had the correct notation. On this one, we're going to start with intercept notation. So a times x plus 1, remember it's always opposite, and x minus 2. And then I'm going to use this point to find a. 1 plus 1, 1 minus 2. This is 2 times negative 1 is negative 2a, and a is equal to 1. You do not have to write the 1. If you just wrote this, this would be correct. But some people like to write the 1 just so they can see it and acknowledge it. So obviously, if you were taking a test and you didn't even think to find A, you would have gotten lucky on this one because you just wrote the equation without even thinking about A. But I'm always going to be looking for the work. On every testing quiz, the answer is always worth 1 point. To get the rest of the points, you have to show the work. So this one is a lot harder. This one, the only way to solve it is to use standard form. You might be thinking, what happened to we don't have to use standard form? I'll show you in a minute. So I would have to plug all 3 of these points in. -1, 4 would look like this. 4 is equal to A times -1 squared plus B times -1 plus C. And then that simplifies to 4 is equal to A minus B plus C. At some point, you're going to see where I'm going with this. 1 is equal to A times 0 squared, B times 0 plus C, which simplifies to 1 is equal to C. And the third one, 2, 7. 7 is equal to A times 2 squared plus B times 2 plus C. Becomes 7 is equal to 4A plus 2B plus C. It's a system of equations. So luckily, we spent chapter 1 learning how to solve systems of equations, although in this case, it is a pretty easy system because I can immediately substitute that in there and in there, which allows me to rewrite both of these as 4 is equal to A minus B plus 1, which is 3 is equal to A minus B. And then 7 is equal to 4A plus 2B plus 1, because I'm putting the C in as 1. So it's not your traditional way of solving a system, but nothing about math is going to stay traditional. And of course, you can solve the system from there. When you do, you'll get A is equal to 2, B is equal to -1, and C is equal to 1. That gives me the equation of the parabola 2x squared minus x plus 1. If you're thinking, you skipped some steps there, that's because I'm going to show you an easier way. I want you to understand this concept that this is a possibility, but we're going to do it on our calculator. So it wasn't that long ago in chapter 1 that we did something called a linear regression. So I hope that you learned that well, because today I'm going to go a little faster because we're doing a quadratic regression, which is pretty much the same steps. For a linear regression, it meant we had a bunch of points and we knew it formed a line. Now we're going to plug in a bunch of points and we know it forms a parabola. So you may remember that the first step was to go to Stat and then Edit. I've already got some things in there, so I go up to L2, hit Clear, Enter. I go over to L1 and hit Clear, Enter. And then I'm going to type in the points that it gave me. So it gave me -1, which went with 4, but I'm just going to do all the x's first. 0, enter, and 2, enter. I go over here, and the corresponding points would be 4, 1, and 7. So it's not a lot of typing. Now I go back to Stat. I want to do a calculation, so I go over to Calculate. And instead of number 4, the linear regression, we're setting quadratic equations. So we're going to go down to number 5. You can either scroll down or you can type the number 5, hit Enter. And it's pretty much just asking you, do you want to use list 1 and list 2? Yeah, I want to use that. Don't worry about the other ones. And then just go down to Calculate. And now instead of it giving you A and B, it's giving you A, B, and C. And you'll see that my R value is 1. It means it has perfectly found it. So those are the exact, how fast was that? No system of equations, nothing. You can just perform a quadratic regression. Just as a review, you could turn on your stat plots by going to second y is equal to, hit enter for the plot 1 on, and then I can hit graph. There's my 3 plots. And now if I go to y is equal to, and I type in, remember they said a was 1, so that's for my x squared. They said b was -1, and then they said c was 1. That's what the regression came up with. And now if I hit graph, I'm going to see the points and I'm going to see the parabola. So it'll help you know that you interpreted it correctly. Anyway, you are welcome to do this problem or any like number 6 using the calculator. You do not have to do these by hand. Moving on to questions for word problem applications. Number 1 says a meteorologist creates a parabola to predict the temperature tomorrow, where X is the number of hours after midnight and Y is the temperature in degrees Celsius. So if midnight is right here, so this is 3 hours after midnight, 9 hours after midnight, 15 hours after midnight, and then all the way until 24 hours after midnight. Write a function that models the temperature over time. So you always have to ask yourself, did it give me the vertex or did it give me the X-intercepts? You might be able to see the vertex, but it's hard to tell exactly where it is, and they didn't tell us. So I'm going to go ahead and use the X-intercepts. Y is equal to sum A that I don't know times X minus 4 times X minus 24. That's where it crossed 0 degrees. So 4 hours after midnight and then 24 hours later. So back up at midnight again. I have a point that I can plug in. Now that point is B. And you might be thinking, oh, does that help us somehow that it's specifically B? Not really. It just makes it easier to plug in the 0. 9.6 is equal to A times 0 minus 4 times 0 minus 24. So 4 times 24 is 96. 9.6 is equal to A times 96. So 9.6 divided by 96 is equal to 0.1. So that's my model. X minus 4 times X minus 24. That means if you wanted to know any temperature or the temperature at any time, if I said f of 1, that would tell you the temperature at 1 in the morning. F of 5 would tell you the temperature at 5 in the morning because it's the number of hours after midnight. What is the coldest temperature? So that's right there, right? The temperature keeps falling and falling and falling. That's the coldest. That's the vertex. Is it the x coordinate of the vertex or the y coordinate? It is the y coordinate. What does the x coordinate tell you? The x coordinate would tell you when it was the coldest. But the y coordinate is going to tell you what actually was the coldest. So how do we find the vertex? The vertex, normally we would have to do negative b over 2a, but don't forget that when it's in intercept form, it's going to be halfway between. So if you're at 4 and then you get to 24, that's a distance of 20, so 10 from either direction. 10 from either direction would put us at 14. So remember I said it didn't look like it was quite 15. It did look a little bit off. So 14 comma something. How do we get that? You always get the y coordinate with the y function. The y function gives you the y coordinate. I am going to switch it to F notation because it makes the work clear. This way, if I'm grading your paper and all you have is just y is equal to, and you plug in a 14, but it's not clear, you do something wrong, then I can't really help you. But if you say, I'm plugging in 14, this is like talking to me and telling me exactly what you're doing. So 14 minus 4 over 14 minus 24. I know it's tempting to get out your calculator, but think about this. This is 0.1 times 10, and then times negative 10. So these two cancel each other out. 0.1 is 1/10. So 1/10 times 10 cancels, and you just get negative 10. Now, should you stop there and box that answer? No. It's a word problem. Answer the question. The coldest temperature is minus 10 degrees Celsius. Okay? Make sure you answer a word problem in a sentence. When did it happen? 14 hours after midnight. All right, this section is a little trickier in my opinion. What is the average rate of change of temperature over the interval in which the temperature is decreasing? So going back up to our picture here, the temperature is falling pretty fast right there. It's not actually falling quite as fast here, right? Can you see that the slope is different? And now look at it. The temperature is falling, but not anywhere near as fast. And now the temperature is not falling at all. The temperature is at the bottom. And now the temperature actually starts to rise. So the rate of change in the temperature changes. At first, it's going down really fast and then not as fast. They want to know the average rate of change. Average rate of change is a fancy name for slope. Over the next several years, every time you see average rate of change, just say to yourself, they just want slope. I mean, I would love for you to understand the concept, but literally all they mean is over the interval where it's decreasing, they just want the slope from there to there. Remember this point, it was 14, negative 10. So m is equal to y2 minus y1 over x2 minus x1. And if you type that into your calculator, it'll come out to negative 1.4. You do need units. Average rate of change in the temperature is negative 1.4. This is in degrees Celsius per hour. Units matter. Make sure you have them. Okay, you should see if you can do the next one on your own. I'm going to jump to the answer for you so you can check it. It's going up, which makes sense, right? Up 1 degree Celsius per hour. That's the answer if you tried it on your own. Good job. But now I will show you how to do it. So when the temperature is increasing, it's not increasing that fast right in the beginning, but it starts to get a little faster. See how its slope is speeding up? And then look at this slope, even a little bit faster. But we want the average slope. So pretty much we want the slope between 14, negative 10, and 24, 0. y2 minus y1 over x2 minus x1, which is 10 over 10, which is 1 degrees Celsius per hour. Okay. Oh, I didn't box this answer. Great. You guys are doing great. Number 2, we have 3 more word problems to go. Number 2 says the graph shows the parabolic path of a performer who is shot out of a cannon. Oh, good. An exciting problem. Where y is the height in feet and x is the horizontal distance traveled. So here's my guy, right? He's getting shot out of a cannon. This is totally cool. Should we put a little fuse on there? All right. So he's getting shot out of a cannon. And when he comes out, he's already at time 0. He's already 15 feet in the air. Oh, it's not time. when he's 0, so at the moment he's leaving the cannon, he's not away from the cannon at all. He's already 15 feet in the air. And then when he's 50 feet away from the cannon, he is now 35 feet in the air. That's his vertex. That's the highest he goes. So can we write an equation for this? Absolutely. Write the equation of the parabola. I'm going to use vertex form. I'm not going to use x and y this time. I'm going to say his height is a times his distance away. You don't have to do this. You can stick with x and y, but I want to show you that sometimes we use different variables to make it clear. Minus 50, don't forget your square. For some reason, very easy to forget that square, plus 35. I need an actual point to find a, but I have one. I know that he was already 15 feet high when he was 0 feet away from the cannon, and he was just popping out, plus 35. I'm going to subtract 35 first so I don't accidentally put it with that square and that a. It doesn't belong there. And then this is going to be a times 50 squared is 2,500 divided by 2,500 divided by 2,500. And I get a is equal to, you can either say negative 1 over 125, or you can say negative 0.008. I'll take either one. So his height is negative 1 over 125. His distance away minus 50 squared plus 35. He lands in a net that is 90 feet away. So at 90 feet away, that's where he lands. He lands in a net. What is the height of the net? So the important thing is knowing whether or not the 90 is the x or the y, but since it's 90 feet away, its distance from the cannon is 90, and you want to know the height, this is how it's going to look. Oops, I wanted to put, height. Negative 1 over 125, 90 minus 50 squared plus 35. You are welcome to enter that into your calculator just like that. I'm not going to do all the little pieces for you. You can literally type it in exactly like that. And you should get 22.2 feet. Okay, 2 more. You're doing great. Before I do the next problem, I actually want you to switch over to page 14, numbers 9 through 11, and I'm gonna show you something that I didn't do in chapter 1. Chapter 1 already had a lot going on, but something that's pretty cool. So if you look at number 10, if I look at how this is increasing, this is going up by 3, up by 3, up by 3. If the x values are increasing at a constant rate and the y values are decreasing or increasing, changing at a constant rate, that actually tells you something. That means that the function is linear. So in chapter 1, we only were talking about linear functions. But what your book is going to do now is when you go to do a regression, you can't assume that just because we're in chapter 2, it's going to be a quadratic regression. They're going to throw in some linear ones. So you have 2 choices. One is you can actually do the stat plot and see if it's linear, or do the stat plot and say, oh yeah, that's some kind of a parabola. Not a perfect parabola maybe, but definitely parabolic in shape. And then you would do a quadratic regression. But there is another way to tell just by looking at the data. And that is that if it goes up at a nice steady pace, then it's going to be linear. What will it do for a quadratic? This is even cooler. So again, this is all assuming that the x value is going up at a steady pace. Okay, so if the x value is going up at a steady pace, then you can find out what the y value is doing. This is going down 8. And then this one goes down 40. And then to get from 376 to 304, this goes down 72. And then to go from 304 to 200 is down 104. And then from 200 to 64 is down 136. That is definitely not linear. If it was constant, it would be linear. But here's the cool part. If you do it again, and it gives you the same value now, it'll be quadratic. So the difference between -8 and 40 is it went down 32. To get from -40 to -72, it went down 32. To get from -72 to -104, down 32. And then the last one, down 32. So if the second, we'll call it tier, like the second time you do it, is constant, then you know that the function is quadratic. Pretty cool, right? So how does that apply to the problem that we were about to do? So this one says that NASA can create a weightless environment by flying a plane in parabolic paths. So it already told you that it's parabolic, but I just wanted to show you how neat this is. So this is going up 5 each time. So the t is constant. So when you're looking at these, the first difference between these is it goes up 2,125. And then the next one only goes up 1,575. This one still goes up, but only goes up 1,025. And then this one goes up 475. And now it actually goes down, -75. And then -625. So because these were not all the same, this is not linear. But then I can do it a second time. To get from 2,125 to 1,575, I would subtract 550. If I subtract another 550, I'll get to 1,025. If I subtract another 550, I'll get to -75. And if I go from -75 to -625, I do that by subtracting 550. These are all the same. I'm on the second level of doing this. It does work again. If it takes 3 times, it's cubic. They're all the same on the second level. So it's quadratic. Now, I'm just going to tell you right now, I never do this. The first year, I didn't even teach this method because it's a little ridiculous. There's so little data in the world that is perfect like this. But the book keeps bringing it up over and over again about using common differences. So I'm showing it to you. But the truth is, I would totally just type this into my graphing calculator and look at it. So yeah, you can go through all this trouble to find out that it's quadratic, but I personally would much rather do it by just doing it on my calculator. The only reason I'm showing it to you is because the directions will say use common differences. That's what this is called, common differences. And I wanted you to understand what that meant. So let's actually do this on our calculator. This one's a little more challenging. So my calculator is still showing the last problem that we did get together. So first I'm going to go to my y is equal to and clear that out. And then I'm going to go to my stats. And I'm going to edit my lists. So I realize that you'll probably be a little faster than me. You're welcome to go ahead and type it in yourself. Enter while you wait patiently for me. Clear, enter. So my x's are 10, 15, 20, 25, 30, 35, 40. My list 2, 26,900, 29,000, 25, 30,600, 31,625. I know that there are some of you that are not actually typing this in. You're thinking, I'll just watch. That's great. I'm not holding your hand. I can't tell if you're actually doing it or not. But I will say you better be able to do this on your own. And sometimes actually typing it yourself is what helps you get it. So the reason I wanted to do this one is to talk about the window. Look what my data is doing. If you want to see this data and you just take graph, you're not going to see anything. Your window probably goes from -10 to 10. I need my X values to go up to 50. And I need my Y values to go up to at least 33,000. So you hit window and you say, I want my X to go from 0 to 50. Don't worry about the scale. And then my Y values to go from 0 to, just going to give it a nice round number, 35,000. And now when I hit graph, my plots are already on. There it is. Ooh, so it just barely tops out, right? So if I actually want the equation, I would go to stat, calculate. I can tell it's a parabola now, so I go to quadratic regression. Enter, 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 calculate. And it'll give me A, B, and C. So my function is y is equal to -11 x squared. Now, it actually is a t in the problem. So when you're writing it on your paper, you should use a t, plus 700x plus 21,000. I hit graph, and look at that, how nicely it goes through. Now, the next part of it says, they wanted to know, after 20.8 seconds, the passengers begin to experience a weightless environment. So at what height does this occur? I want to know what height they are at 20.8. So since that 20.8 is the X value, here's a cool thing you can do. Second, calculate. Whenever you want your calculator to calculate something, it's second trace. And I want to know the value. It just lets you pick it. I'd like to know it for 20.8. You hit enter, and there it is. It'll be at a height of 30,800.96. You do not need to add the 0, even though I told you 3 places. If it's only 2, it's only 2. Okay, everybody. For this last example, I'm going to do something that I haven't done yet, and that is I am going to make you do it mostly on your own. And here's why. Because I think that if I just type it all in for you and do all the steps on the calculator for you, I understand that there's no work for you to show on your paper. So in this case, I would like you to write the following on your paper. I would like you to perform the regression, write down what equation you got. I'm actually going to be checking it. You can check it with a friend. I'm fine with that. And I want to know what window you used to make it. So this is how mine ended up looking. And I do want to do the last part of it, though, for you. So this table is showing you, given a certain number of miles per hour, so the x-axis is going to be how many miles per hour you're going, and then what your miles per gallon are. So there's an optimal speed. There's a miles per hour where you're maximizing your miles per gallon, how many miles you're getting for each gallon of gas that you're putting in your car. So this is really good information, actually. What is that maximum going to be? It's going to be the vertex. So I want to show you again, I think I've done it before on your calculator, how to find that. But what you're responsible for doing is typing in the y is equal to in the correct window to get to this screen. So second, calculate. I want to know the maximum. So I go down to 4. I hit enter. And for my left bound, I am to the left of the maximum, and it's saying 40. It's a perfectly good left bound. Now for right bound, it's still saying 40. Right? It's not that intelligent. I need to get over that hump. If I don't have a number in my head, I can just keep scrolling until I get there. I'm definitely to the right of that vertex now, so I can hit enter. It wants me to guess. I'm not going to guess. I'm just going to hit enter. Look at that. It found me the maximum. So what this means is if you're going 48.786 miles per hour, so almost 50 miles an hour, you're going to maximize the gas ratio in your car. You're going to be getting 26 miles to the gallon. Okay? So that's how you use that function, but the rest of it, I am going to be looking at your paper. Please make sure you write down the regression that you came up with in order to do this problem and the window that you used in order to be able to see it. All right, we're done for today. Have a great day.